Here we are at Pond City Market. Behind me, you can see a map of Pond City Market. Today, we're going to talk about the importance of maps and why geographers use maps to study space. I'm Mr. Coulter, and this is Human Geography. The first topic of Unit 1 is an introduction to maps. We're talking about maps today as our starting point because maps are one of the most important tools that geographers have in their toolkit in studying the Earth. So let's start with what is a map. A map is a two-dimensional scaled representation of the Earth's surface. Maps show spatial data, which is data with a locational component, so that people can understand it. So we take our 3D globe and we try to project it onto a flat surface to better understand. But as we look at maps, let's start off with one that might look a little unusual. This is an upside-down map of the Earth. In terms of everything that we talk about accuracy with maps, this map is accurate of the Earth. You can see that everything's where it's supposed to be. The sizes look like how we imagine the sizes, and the latitudes and longitudes are there. But the thing that's different than what we expect is the Earth is upside down. They flipped the North and the South poles for this map. It's important for us to understand that the way that people make maps is based on their perception. So maps are saying something. And this one is showing us that it's arbitrary the way that we make the United States and Canada in the northwest part of the map, since the map could be any direction we want it to be. So who makes maps? Cartographers are the people who make maps, and cartography is the art of map making. Cartographers have important decisions when they're trying to figure out what they want to put on a map. The first one is projection. How do they want to transfer the image of a 3D globe onto a flat surface? Simplification, how are they going to break down that information in a way that people can understand? The scale, how much area is covered on the map? The aggregation, which is how do you break up that information once it's on the map? And then the type of map, is it a thematic or a reference map? So we'll start with map scale. Whenever map makers are trying to decide how they want to make the map, they have to look at the ratio of the distance on Earth to the distance on the map. They're often measured in the same units. And what we see is that a smaller scale map shows more land area and less detail. So we use it to show global patterns or national patterns, where larger scale maps show less land area and more detail. Those are what's used on local maps. So the name is reversed from what you might expect. It's because the fraction is smaller of a more zoomed out map. So try to understand that a smaller scale map, like we have on the left of Georgia, is more zoomed out and shows more area than a larger scale map, like what we have in Alpharetta. So Alpharetta is a larger scale map than Georgia. That's important for us to understand. The smallest scale map is a map of the whole world, and then it gets larger as you zoom in. So again, smaller scale Georgia, larger scale Alpharetta. That'll help you remember the way that scale works, because sometimes it's confusing to people. So a reference map is a map that shows reference information for a particular place, making it useful for finding landmarks and for navigating. So if we look here, we have a topographical map of the United States that also has all of the major highways on it. So if you look, you could trace the interstate system. You may use maps like this for planning road trips or for anything where you're trying to find basic information about what is physically there. A thematic map is one that we're going to look at a lot in this class because that's helping us to understand some form of data. A map of this type displays one or more variables, such as population, income level, within a specific area. So we have all this information in a thematic map that you can show, and we're going to get into what those look like. This example right here is a thematic map that shows plant hardiness. You can see the trippy lines that help you to see where plant hardiness is in different zones. I think only botanists would use this, but I thought it looked cool. So there are a lot of different types of thematic maps. And before we start studying them, we have to understand what each type of thematic map is. So let's look at the first one, which is a categorical map. Categorical maps depict areas that are different in kind. So they use several distinct colors to show different categories. Some examples of this would be climates or religions. So what you would do is you'd use different colors to show different types of climates around the world. This one is a religion map, and it helps you to see the different religions in different areas of the world. It also colors the different sects of major religions differently so that you can understand where the different groups are. So you can see in the Americas, you have a lot of Catholicism in dark green, but then you also have the pink of Protestantism and then also Mormonism on there. Same thing with Islam. You can see that Sunnis are the biggest Muslim population around the world, where you just have a few Shia in Iran and other areas around Iran. Next, we have choropleth maps. Choropleth maps are ones that use the same color or two colors at different shades to show different values. So they show different stats based on how shaded in the color is. You can see the population of the states with a 4-year degree of the United States right there. And you can see the darkest ones where they are, and you can also see the lightest are West Virginia, Kentucky, Mississippi, and Arkansas. And Arkansas, even if you have a 4-year degree, it might be from a college that calls the hogs. Look it up. That is a real thing that Arkansas does. So this is helpful whenever you're trying to compare things like population density, literacy rates, all of that good stuff. An ice-line map uses lines to connect points of equal value. So we show different information that's connected. You can see the average temperature map on the right. So all of the places where the average temperature is 70 or above in February are connected with an orange area by lines. And then it goes out to 60, 50, and so on as you look at the country. So things like temperatures or elevation are really easy to see with isoline maps. A dot density map uses a dot to represent the frequency of a mapped variable. So this is a population map of the United States. It looks a little weird because everything is darker on the East Coast, but that's the much more populated area of the United States. So a dot density map helps you to see how much of something there is. So sometimes people will use this to do population or talk about where businesses are or fans of a certain school. There are all sorts of different things you can show with a dot density map. Again. Cartograms are really interesting because it's a map in which you take the theme or whatever variable you're mapping, and instead of using the land area or distance, you substitute in that data. So this is a population map of the world, but it's distorted to represent how many people live in each of those countries. So there's a square for each million person. So if you look, China and India are so much bigger than the rest of the world because they have over 1.25 billion people in their countries. And it shows that some countries look a lot bigger than you'd think, like Japan expands, or Indonesia, and then some countries shrink, like Canada and New Zealand shrink down to become almost non-existent. It helps us to see the information on a scale that it really highlights the major outliers of that number. So you can use this for all sorts of things like time of travel, GNP, population, like we said. Cartograms help you to see it on a way that looks unusual in terms because they're distorting the area. A proportional symbol map is a type of map where they show the size of something and then the intensity of the mapped variable. So this is an earthquake map on Australia. And you can see the impact of the earthquakes are covered in how big the circles are. So if it's a bigger circle, it shows that the earthquake was much bigger. That's a graduated circle type proportional symbol map. There's another type of proportional symbol map called a flow vector type. That's where you use arrows, and then the size of the arrows help to represent how big the phenomenon is. So this helps a lot with movement or migration, where you show people moving, and then the size of the arrow says how many people are actually moving, like this migration map of the United States. So we've talked about all of the types of maps, but now we need to think about when cartographers are making their decisions. They have to decide how they're going to take a 3D surface and turn it into a flat map. And when you do that, that's called a projection. When you project the Earth's surface onto a flat surface, that is a projection. And no matter what you do, you're going to distort something when you're turning a 3D image into a flat one. Think about a balloon. If you draw on a balloon when it's full of air, and then you take all the air out and flatten it out, it's going to mess up the drawing that you made in some way. And so cartographers' jobs are to decide what they're going to distort and what they're going to preserve. So something is going to change when you do that. And we have to decide what do we want to keep and what changes. And that is called distortion. So cartographers have to decide which of these traits. And whenever they have to do that, it is called SAD, because the traits are shape, area, distance, and direction. So SAD is SADD, shape, area, distance, and direction. So those are the things that they have to decide what traits they're going to keep or distort. So we're going to look at a few examples of this. The first one is the Mercator projection. The Mercator projection was made in the time of discovery, so when sailors were sailing from Europe around the world. So the problem with the Mercator projection is it distorts the land area. It gets the distances and the lines of longitude and latitude correct. They make very accurate sailing directions, but the problem is the land masses are completely distorted. So if you look at Africa and Greenland, Africa looks a little bit smaller than Greenland. In reality, Africa is 16 times bigger than Greenland. So it makes everything at the poles look huge and everything at the equator look a lot smaller. And because of this, it distorts the way that we perceive those places as well. So the Mercator projection really messes up the shapes and the sizes of land. The next is the Robinson projection. This is one made by an artist. And as you can see with the Robinson, it's one that you're pretty familiar with. They have no major distortions, but all size, area, shape, and direction are slightly distorted in order to best preserve all of them. So everything is a little bit distorted, but they try to preserve the integrity of the whole globe best as they can, included the curved edges to make it look more similar to a globe. So the Robinson projection distorts everything a little bit in order to preserve most things. The next one is the Peters projection. The Gale-Peters is the most accurate of land area of any map. The problem is that it looks very different than what we're used to looking at. So you can see the size of the land masses are accurate. Africa is as big as it's supposed to be. The poles look the way that they actually look on Earth, but it distorts the shape and the directions on the map. So when you look, the United States and North America looks a little different than we perceive it. Same thing with South America and the parts of the Pacific of Asia. All of those look different than the way that we're used to. It gets all the land masses, right? Africa is its correct size. We can see everything on the map looks correct, but it looks very different than what we're used to when looking at the Earth. There are a lot of very cool different projections. We're going to take some time to look at some of the more unique projections out there. But all of these projections are accurate portrayals of the Earth. They're just in different ways of choosing to project them. Next, we have the map aggregation. Aggregation is the level of detail for dividing a thematic map into geographic units. So that's when geographers decide, how are we going to split up the information so people can understand it? So here are 3 examples of maps. This is vehicles per 1,000 people, but it's aggregated by country. So they decide to break it up at the country level. So you can see each country's level of how many cars per 1,000 people. So you can see the highest in the world is US, Canada, Australia, and parts of Europe and Japan. And then it gets to the lowest in parts of Central Africa. But if you really wanted more information on within a country, you could look at how it's aggregated by state. So if you took the US and you aggregated this information by state, you can see number of vehicles per capita, so that's per person, in the United States. So you can see the states with the highest, like California or Virginia, or the states with the lowest, like Nevada. So if you aggregate by state, that gives you a little more information. But if you want even more detail, you can aggregate it by county. So this is the average number of vehicles per household, and you can see every county in the United States. So aggregation is important because it helps us to see what detail level you want of the information. So next we have location. Location is something that is instrumental to us understanding geography. As we think about places, we have to understand location. So there are 2 different types. There's absolute and relative location. Absolute location is the precise point where something is on the map. So you use some system in order to see where something is. So if I used a coordinate system or an address, that would give us our absolute location. A relative location is saying where something is relative to other things. So you'd say Salt Lake City, Utah, is located just south of the Great Salt Lake. And it helps you to understand where it is. Same thing if I said it was just west of the Rocky Mountains. You're using landmarks to understand where something is. Absolute location has a lot of different uses, but it helps us understand really in reality where it is, not relative to something else. So latitude and longitude are two ways that we decide on where an absolute location is. That's the coordinate system that our GPS uses. So latitude is the distance north or south of the equator, and longitude is the distance east or west of the prime meridian. The prime meridian passes through Greenwich, England, and the international date line's on the opposite side of the earth. That's at 180 degrees. So again, latitude goes laterally around the earth, and it tells you the distance north or south you are of the equator. Longitude runs the long way over the poles, and it shows you how far you are from the prime meridian, west or east. Relative location is often described in connectivity. So how are two places tied together? Is it by roads or is it by information links? What is the accessibility of the place? Is it easy for people to get to different places or how quickly you can move? This can change over time as accessibility changes. So an example of this is there are ghost towns out west that are abandoned settlements. They once were very important because they were along the routes to gold mines or oil fields. And then as they were abandoned, they closed down and then the city became extinct. So those are examples of like how your relative location become less important if things don't exist anymore. The relative location loses that advantage to the resource or the trade, but the absolute location is the same. The ghost town hasn't moved. It's just the thing that made it prosperous has left, so people leave the town as well. Distance is another thing that we have absolute and relative of. Absolute distance is a precise measurement in miles or kilometers. So that's saying that Cambridge High School is 4.9 miles away from Milton High School. That's an absolute number that I can tell you that you understand. But a relative distance is about that spatial interaction, the contact, the movement, the flow between two places. So if I gave you like an estimate of like Cambridge is 15 minutes away from Milton, that gives you an idea of relative distance. The other thing about relative distance is that it changes over time with connectivity. So online shopping is something that the relative distance between products and consumers has changed drastically. If you think about Amazon Prime has 2-day or 1-day, sometimes 2-hour delivery. And that means that the relative distance of having to get to a store has changed where on your front steps 2 hours later, you can have batteries delivered if you need them immediately. All right, that's it for topic 1.1, Introduction to Maps. The major things that we learned about were the different types of maps and the thematic maps that take us through, what decisions cartographers have to make, including the projection and the scale of the map. And remember that a larger scale map is actually more zoomed in and shows less area, where a smaller scale map is more zoomed out and shows more area. We also talked about the projections and the way that they distort the Earth. Remember, all maps are a distorted version of the Earth's surface. And then we talked about absolute distance and location. Make sure to study those things, and that's one more step in the journey to better understanding your world. I'm Mr. Coulter, and that was Human Geography.